Hi, my name is Ali. Let's talk about TMC or VMware Tanzu Mission Control. This tool is for multi-cloud Kubernetes fleet management and operations. If you haven't seen my previous video where I touched on the topic of Kubernetes operation across multiple clouds and why this is so important, please go watch that video. This video is predominantly focused on demonstrating the capabilities of mission control. So, okay, so first things first, we need to register Tanzu Mission Control with clouds and or cloud fragments. What I mean by cloud fragments is, let's say we have 5 different accounts in Azure cloud, right? So that means there are 5 cloud fragments that is within the organization. One fragment could belong to the Southwest, the other can belong to the US East or US West data center, and so on and so forth, right? And same, the cloud fragment concept also goes for on-prem data center as well, and so in AWS. So with Tanzu Mission Control, we need to first register those cloud fragments so that we can start creating Kubernetes cluster in those clouds. But like, I will make a separate video on how to register that and how to get it started with registering a cloud fragments. But after registering how those cloud fragments we will be able to use, I will demonstrate that in this video. All right, so organization. So organizing the Kubernetes cluster and its namespaces is super important when we are dealing with fleet of Kubernetes cluster. And that's where concept called cluster group and workspace comes into place. In cluster group, as the name suggests, it is where we can group multiple Kubernetes clusters, like the actual clusters, in a group. And the reason we do that is so we can operate or apply governance and security policies across the entire group. The reason there is, let's say you have 10 Kubernetes cluster in your dev environment and 5 Kubernetes cluster in your prod environment, and there will be different governance security policy that we'll need to apply on all the clusters on dev environment versus all the cluster and prod environment. That's why we can group them under a grouping called dev, and then we can group in called prod. And we can apply different set of governance and policies in these two different groups. So that's how we keep Kubernetes clusters in group and organize it in a logical manner. The second one is workspace. So this is predominantly grouping of namespaces. So you can group multiple namespaces that which can spread into different Kubernetes cluster across different clouds, and we can apply the policies, different policies according to the namespaces. So, for example, let's say we have an application and there are multiple components of the application that's getting deployed, but the payment microservices associated with the payment functionality of the application will belong to a different namespace. So let's say it starts with payment. The namespace is called payment. So we'll apply different set of rules and policies in that namespace versus the portal the microservice associated with achieving the portal functionality of the application can belong to a separate set of namespaces, which you can group them together under workspace, and we can apply different set of governance and security policies of those workspaces. So these two concepts are very important, and I will demonstrate in a bit what those are. The second one in here is the lifecycle management of the clusters. Let's say we have a fleet of Kubernetes clusters that's available, and when I say lifecycle, that actually implies three types of operation, right? So it's create, delete, upgrade, and there's patching, but upgrade and patching is pretty much the same thing in Kubernetes scenario. So that's very important. Like, we can't go in one cloud at a time or one cluster at a time and do these 3 operations there, right? That's just not a feasible scenario when we're dealing with more than 5 or 6 different clusters, right? In production grade scenario on an enterprise, there are typically at least 50, if not more, clusters there. And mission control makes this process super simplified. So when I will demonstrate, it will make more sense. Then there is access control. So you all know this one. So I won't go into too much details. It will be I'll demonstrate this instead. And then in Kubernetes, everything is policy-based, right? So whenever I say governance, and I also use the term security, these are enforced on a cluster using something called policy. What Mission Control uses is a tool or an open source project called Gatekeeper or Open Policy Agent Gatekeeper. And these policies are, there are a couple of baked-in, built-in policies in Mission Control, and we can always create, if those built-in policies don't meet the thing that we are trying to achieve, we can always create custom codes and store that inside Mission Control, and we can apply that against cluster grouping or workspace across fleets of clusters. Right. So let's get down to the demo, which is the important part. What I will do, I will switch back to the Mission Control. So what you can see here is clusters from different clouds. So I have 3 on-premises cloud, Data Center 1, Data Center 2, and Data Center 3. And I also have Azure, and I also have AWS, right? And immediately, one thing you can notice is Mission Control is telling me that, hey, there is a new version that's available, so upgrade available. And I can show you like how simple this upgrade process is. So I could just simply go in and click upgrade, and it will prompt me what are the versions above that whatever the previous version was, 1.19, that's available in AWS. So I will select the most up-to-date version, which is the top one here, and I'll select upgrade, and the process will kick in shortly. So Mission Control has already started upgrading this cluster to a newer version. So that's one. Let's create clusters, right? But as I mentioned, there is grouping and there is namespace. I'll quickly familiarize you what I mean by that. So in this particular case, I have 2 groups, and the cluster you saw, these are in one group, right? So for demonstration purpose, what I will do, I'll create clusters in the second group, which is empty. Let's imagine this is a dev scenario. This is a dev group. So I'll create a cluster, and when I go in and create a cluster, you can see that I have multiple data center connected in Mission Control. So one of them is Azure, and this one is on-prem data center. There's 3 of them. So I will use data center 1, and I'll go in creating a cluster. That's a provisioner. The name is DC1. Let's call this test 2, or test 27. And then the version of Kubernetes that's available in that data center, right? So in this case, I'll select the top one, the most up-to-date version. I'll keep the defaults as it is. I'll select the storage policy, the storage class, and then the size of the nodes, I'll select it from here as well. So in this case, I'll select a medium size, and I will say number of clusters. I'll keep it for demonstration purpose. I'll keep it 1, and then I will also select medium in here. And there are different configuration that I can put in, but for now, I'll keep it simple. I'll just create this cluster. While this cluster is getting created, then in the meantime, what I will also do is inside the cluster group, I'll create another cluster. This time I'll create it from Azure. The provisioner is default here, subscription that. Cluster name, let's call this AZ1 test 27. Of that done, and I'll use US2. I'll select the top one. It says public key. I have a public key stored. I guess this is my public key. Yeah, of course. Copy this public key. Paste it in here. I'll create a new VNet. That's okay. Go next. Control plane size. I'll select a little smaller one. And for demonstration purpose, I'll keep it simple as well. So this cluster is on its way. Yeah, so the cluster, we'll see like it has started creating. Right? So that's good. The clusters are creating. So what I've just done is I created two different clusters from two different data centers, and it took me just a couple of minutes. So as the cluster is getting created, I will move on to demonstrating some of the other quite important functionalities. So before I go ahead and do that, I'll quickly show what the view that Mission Control provides. Right. So here I can see there are two nodes. One is the control plane, and the other one is the worker node. If I choose a little bit bigger cluster, let's see. I can see the summary. So this one has got 4 nodes, right? So I'll go into this cluster, and I can see inside nodes there are 4 of them. I'm only using one node pool, but I can create another node pool, or I can edit the existing node pool and increase the number of it. So in the case like when we are not doing auto node scaling and we want to control the number of nodes a cluster will have, this tool is great. I can control it from here, and I'm not even worried about which cloud it is in. I can see the namespaces that's there, so I'll hide the system namespaces. So these are the custom namespaces that I have. Also the workloads. At the moment I don't think I have. Oh, there you go. So these are the workloads that are running in there. Add-on, that's an interesting side of things, is in my previous video I was mentioning a feature of software catalog. So if I go into cluster group, let's pick a cluster, let's say this one. I go on add-on, and I can go into, oops, not this one. I can go into browse packages, and I would be able to see that the custom software that I'm supplying from here. And also the built-in packages. So this can act as a software catalog through which I can deploy a new software onto the cluster. I go to the groups again. Let's see what other information we have available in this cluster. So obviously namespaces, we saw that one. I can do secret management from the cluster as well. And I can create a secret name. Let's say Docker Hub namespace, put it in custom, and then it will be Docker. I can give my username and password in here too. So that way I can create the secrets too, and I'll be able to rotate the secrets from here. Then there is inspection. So this is predominantly on CIS benchmark. So I know, like from auditing perspective, this will bring in significant value. And then there are events as well. So I can see a few things that happened in there. One is failed and will notice me. So that's a quick overview of what Mission Control provides at a glance at a cluster level. Obviously, this is not a substitute for something like a cluster viewer, like Octant or so on. So what I had gone ahead and done for demonstration purpose is I have connected, I use, oh, by the way, one other quick thing is accessing this cluster. So this could be a self-service as well. So it's as simple as long as I can provide so I'm the administrator, hence I have access to everything, but I can provide a view-only access to the engineering team who can log into this platform and get visibility only the cluster they are given access to. And I'll showcase like how those access will be given. But to access this cluster, I can simply come in here and click on access cluster, and I can either download the kit config file or copy it from here or get the URL to get it downloaded. So that's pretty good from cluster management perspective, like and sales capability. There is also so now I will switch gear and discover a little bit on the workspace side of things. So I have my own workspace in here, and as you can see, I have created a namespace in this workspace. So let's create another namespace in another cluster. So I have on Azure and I have on Data Center 3. So let me create another namespace called custom. Description is fine. Cluster, I'll go DC1 test1. So let's create a namespace in there. And then in label, I'll just say, demo. Let's just say that is equal to custom. That's pretty much it, and I'll just create this namespace, and the namespace will be in here. So the difference here, like these namespaces, Mission Control will be able to manage it as well. So you can create your own namespace in the cluster. There is nothing forbidden from that perspective, depending on the permission that I'm giving to the user. Sometimes I want to give permission to the engineering tech lead so that they can create their own namespace. They can create the namespaces for the team. But if I am controlling that as well, so this is a great way to do that. All the namespaces have got certain tags associated to it. So one of such tag is this tag here. So I'll just copy it, and I'll use it in a second. So now we saw the namespace and how they are grouped. They are grouped inside a workspace called NIWS. Also, some of the powerful features in here. Right, so one of the feature or one of the things that organization often does is restricts where the Kubernetes can consume the images from, right? So in this case, I can apply that restriction. So the way I'll go ahead and do that is I'll go into the policies and I go in image registry and I'll select my workspace and I'll create a new policy. And I'll say, I'll go in custom. So here I'll say policy, and I'll say only allow from ACR, for example, right? Then in this case, I can provide a hostname, which will be all, let's say, the ACR.io. That's where the images will come from. I don't mind the image name. I'll just restrict the host name. And then I'll add this rule. So now I have restricted to only ACR. I can add more hostname, more container registry, but for demonstration purpose, I will just use the ACR. Label selector. Now, this is where that label that I copied will come in handy. So include only specific namespaces, right? This is the namespace. Okay. So I'll use the label selector as WS. Go ahead and apply that, add label selector. So now I can specify the namespaces that will only belong to that label space, just in case. In this case, like all my namespaces are custom, but let's say there are other namespaces there, so I can further filter it from there. Now I'll just go ahead and create this policy. So now that the policy is in place, what I had done is I had what I had done is I had gone ahead. Oh, by the way, this cluster got deployed. It's done. I had gone in and grabbed the keep config file for 3 clusters. Test1, Azure Test2, and DC3 Test1, and I have spin up 3 Octant instance. So this is specifically for cluster viewer, and it's an open source tool. You can go ahead, you can Google Octant and use this to view your cluster as well. So I'm using Octant to visualize what's happening in my cluster, and I have the namespaces here. So this is looking at DC3 Test1, and this is the default namespace, and I have the custom namespace here. And I have a console because I'm running on, I have gone ahead and grabbed the keep config file. So on this console, I have access to that cluster. So I could go kubectl get namespace, and it should bring in the namespaces in that cluster. Okay. So what I'm going to do is in this directory, I have 3 deployment files. They're very simple application, basically a deployment definition, name is simple greetings, and the image will come from Docker. So, but what I have done is I have only restricted to acr.io, right? So it should restrict a deployment where the image is coming from Docker Hub. And in Organizer, this is a very practical scenario. Unless you have an enterprise Docker Hub account, which you can restrict it to. Otherwise, you'll need to stick to your image registry, not everything from Docker Hub. Not all the containers in Docker Hub are secure. And there is a service as well, so I'm exposing port 80. So that's pretty standard, pretty normal. So what I'll do, I'll go ahead and do kubectl apply -f deployment this one, and I'll apply this to custom namespace. Right? So it will go ahead and deploy, create the deployment, and it will create the services as well. We can see the Octant got updated, and there's an error in the replica set, right? Basically, it couldn't bring up the replicas to that. So what I'll do, I'll go ahead and see in the event section, and I can immediately see that the gatekeeper policy has said only allow from ACR. That's basically the policy that I had just created, and it is trying to come from here, but only allows host names are ani.acr.io. So obviously that's why it's not going to work. So that means the policy that we had set up in our assignments against our namespaces are applicable there. Right? So this policy, so this policy is inherent. It's in effect. And these policies, there's a good thing on this one is it's also hierarchical based. So you can see I've got an org hierarchy, and here I have a policy set up that says like it will require digest, and then at the workspace level I have said this custom policy, only allow from ACR. Right? So the same thing will happen if because in that, remember, like in that workspace, I have clusters from 3 different data centers, right? One from Azure as well. So that's an interesting thing. So let's see on the Azure cluster. So if I go in here, in the custom namespace, I should also be able to see that policy being applied there. So basically, there should be a policy here. So that policy is also applicable here. So if I try to deploy in the Azure, which is running on 25, which is this guy here, so I go in Kubernetes directory, I'll do kubectl apply -f custom, and we'll try to create the workload as well. This will fail with the exact same error as the other data center, right? So so that means that policy is working across all of the cluster. And if I bring in another namespace into that group, into that workspace group, I don't have to do anything. It will just work. That namespace will just be in effect. So that is the onboarding experience that I was talking about. So for example, the new cluster that I created. So let me quickly access the cluster. So I go in cluster groups. I created a new cluster, which is DC127. Actually, I'll just use the Azure cluster here. This one, and I'll do access this cluster. Copy this file. I'll paste this. And what I can do, I can simply So I have switched into the newly created cluster, and I go in namespace overview. That comes up. There is only default namespace, no custom namespace in there. What I will do from TMC, I'll create a new namespace in that workspace area. Let's go create namespace. I'll call it custom. Cluster is Azure 1 test 27. That's my cluster there. For label, I'll just skip this part and I'll create a new one. So Octant will be able to take that. So if I go in there, now there is nothing deployed there, but what will happen is if I look at the cluster view, not this one here. So that policy got applied in that cluster as well. It took a few seconds, but it got applied. So TMC made sure that it automated that. So that's what I meant by configure once and onboard many times. So I could just go ahead and do kubectl delete -f deployment -n custom namespace. I'll delete this one. So now the deployment is gone. And what I'll do from mission control, I'll go ahead and in the assignment section, in the image registry, under this cluster, I'll go ahead and delete this one, this policy as well. So once I delete this, it will delete from all of the namespaces under this workspace. Okay. So I can view that from Octant as well. So in here, the policy has already gone. Even if I switch to the second cluster here, it's still changing context. I'll wait. If I look at the policy, so that policy is now gone. Now, if I try to deploy this again, so I'll switch to the namespace, custom namespace. And I'll try to apply. Now this will work. It will take some time, but it will come up. So this is now green. The application got deployed. So if I look at the services, I think my service is available at this IP. The external IP hasn't come up yet. I'm pretty sure I deployed it as a no. Oh, this is deployed as a cluster IP, so that's why the external IP hasn't come up. But like that demonstrates the image restriction. There is one other demonstration I will do, which is around the resource quota. So I'll delete this one again. So that will be gone. Okay, so the second demonstration I will do is around the resource policy, resource quota. So here I have created my own policy, which is a custom policy that says deny pods without CPU limit. And this is a gatekeeper policy, which is open source project. And most likely, if you are going to apply governance and security policy on your Kubernetes cluster, you're probably going to use gatekeeper as well. So mission control uses gatekeeper as its backend engine to enforce these policies. So one advantage is if you take away mission control, let's say 1 year down the track, your policy that you have applied will still be applicable and you will still be able to manage it. So what I will do is I'll go into the assignment section again, and under custom, I will apply that against all of this cluster, right? So I'll go create custom policy, and I'll choose the CPU limit policy. I'll give block without CPU limit. I believe this is pod, and it will also pod template and label selector. So I'll use the same label selector because that's where all of my labels are. So I take that one. So include only specific namespaces. Otherwise, it will apply to all of the namespaces in this entire cluster, which I don't want. Right? So that's how I'll filter it down. So the GUI actually makes it super simple. So I'll go ahead and create this policy. So what will happen is in Octane Viewer, I should be able to see that policy getting applied in, let's say, in all of the clusters in there, right? So let's say DC3 test 1 was one of those clusters. And if I go in there, the policy is called constraint template. So this one here, and deny pods without CPU limits V1. So that is in DC1. Let's see what's happening in the Azure cluster. So I should be able to see that policy coming up here as well. And there you go, that policy got applied in that cluster, and then in DC1 test 1 cluster 2. So I should be able to see that policy there as well. So now the policy is there. So if I try to deploy a deployment into, let's say, in my DC3 test 1 again, which is this console here. So I'll try to apply this thing again. So let's say I apply this. So this one has got no resource limit. So what will happen is I should be able to see an error coming up. Custom, again, the replicator got errored out. If I look at the events, now allocating waybook policy container simple unit does not have a resource CPU limit set. So that's great. That means that policy is in effect. I can go ahead and delete this. And so simple gridding should be gone now. I also have another, not this one, sorry. Yeah, so I also have with resource limit, right? So this is where I have defined the CPU limit. I've also said the memory limit. That's all good. So I will go ahead and deploy with resource limit on it, which is this thing here. So I'll apply it now, and it should get created without any issues. So it will come up green soon. Okay, so it took a few seconds. It took about a minute and a half to get to the green stage, but the pod got deployed and the workload is now up and running in the cluster. So what I wanted to quickly recap on now, so we saw creating Kubernetes cluster across multiple cloud, so that was pretty good. High level overview of the information that's available. We upgraded a cluster and TMC notified us that an upgrade is available. We saw how to access the cluster. We saw how we can enforce a policy that will, how we can create and apply a policy across all the cluster that will enforce a resource limit to any workload that gets deployed. We saw approved registry. This one I haven't demonstrated, which is again pretty simple. The last one in here, and we saw the software catalog that's available there. The last one here is the access control, and the only port allows is 3000. So that's pretty easy to achieve as well. So if I go in the assignment, and I believe that policy is under probably network policy, and I can go in and create custom ingress rule, and I can say, only allow let's say only allow 3000, right? And I can give an allow IP range, which is 3000, and any IP range that is exclude. I can do that. I'll do add source. Oh, sorry, that's IP. I don't want to do IP. I want to do port. So port is 3000. I can do that. So add port label selector. Again, I will apply the same label on create the policy. Right. So I want to apply this policy now. And the last one is the access management. So on the access management side, it's again pretty simple. I can provide access cluster-wide. I can also do access namespace-wise. And basically, let's say in the namespace, if I wanted to provide the engineers access to the namespaces that are under in this workspace group, so pretty much all the namespaces called custom across the cluster, and I could have different combination of namespaces in here as well. I could go ahead and create, let's say, workspace edit role to an user, and I could say this user will have workspace edit role in there, and the user will come from LDAP or the integration that TMC has in the cloud side. And I'll add that, and that will become available against all of the namespaces there. So if I go into Octant again and the namespace view, and I could go in RBAC. So that's the RBAC that I just created. So that user is now there. I can add another user pretty quickly. So let's say I'll just go edit this one and add, although this user won't work because the SSO access doesn't exist, but for example demonstration purpose I could show that the RBAC is getting applied and that new user is now available. And that's not just on test cluster. I can see that in the Azure cluster as well. So I go in RBAC, overview. This is the one that I just created, and 2 users there. So that's pretty neat. So TMC kind of sorts out the access as well. And again, the same rule applies if I create a new namespace here. The access in that namespace will also become available. So for example, I could go in the workspace inside that, and I could create a new namespace. Let's call this sample, right? And I'll apply it to only Azure cluster, and that's it. So because that namespace will come under this one, so the same assignment policy that we just created here, that will also go inside this namespace too. So let's have a quick look what happened in through Octant. So in Azure, I should be able to see sample here. Go in RBAC, and the access immediately got applied there. So that's as like what I meant by configure once and onboard many times, repeating that. So we saw the access control as well, and how a port is like custom egress policies can be applied in there too. And then the last thing I wanted to quickly demonstrate is is the ability or the feature in mission control to streamline the integration of observability or monitoring tool. So I'll quickly add that in here. Oops. So what I mean by that one is in the terms of mission control, the cluster grouping that I have. So for example, this one here, there is a tab in here that says integration, right? So in here, I have already gone ahead and integrated the Tanzu observability tool at the group level. So at this group. So what that means that every cluster that I created inside this group will automatically be integrated with Tanzu observability. So for example, if I take one of the newest cluster that I created, which is AZ test 27, I just created during this demo, I can see the integration with the observability is already available there. So I could click on it, and I could go ahead in the observability tool. I can see that it's with one node, there's one active node, 4 namespaces, 16 pods, some basic metrics there. And from here, I can also configure alert on this cluster and the application. Now, this monitoring tool, right now the way, because I clicked on this link, clicked on the link from a specific cluster, so it's filtered at the cluster level. But it actually is a SaaS-based monitoring tool, and it's filtered to that cluster level. There are all the other workload cluster in there that it is also monitoring. So this topic, I'll make a separate video to cover off the monitoring topic. What do we have covered? So this streamlined observability tool integration is also a feature that is available in mission control. If I'm not using Tanzu observability like this way, then I can always fall back through the catalog option and deploy Prometheus and Grafana from here on every cluster. So this is where so that concludes my demonstration of Tanzu Mission Control. Please feel free to reach out if you have any questions. And with that, I end this video. Thank you.